Okay, so in today's class, we will see set operators, joins, and subqueries. Okay, these are also part of SQL. And before going to these concepts, let us see two important concepts that is called data dictionary, data dictionary, and metadata. So these are the two important things which we need to understand uh, as part of ETL testing. Okay, so metadata, data dictionary, metadata. So when you work in ETL testing, so you need to have something like you need to know what are all the different constraints have been created in the table and what is the structure of the table, what are the data types of those columns. You want to get this data for more tables, per number of tables. So how we need to get the data? So basically this kind of data will be stored in the system tables in Oracle. Any database, basically this data will be available on the system tables. The data is called as a metadata. Metadata means a data about the data. So for example, if I say a table which contains the columns is having each column having a different kind of data type. So if you want to know all the columns and their data types, that is basically called as metadata, data about the data. And where we need to get this kind of metadata from dictionary tables. So any database we maintain a certain kind of system tables. So in the system tables the data will be available. So there are two types of tables available in database. Two types of tables. One is system tables. System tables means these tables by default will be there when you install Oracle. The system tables will contain the all the database information, tables information, user information, and so on. All system related data will be stored in the system tables. And these tables we don't create, by default it will be there. And the other category is user defined tables. So user defined tables are tables which we have created. So we know all the tables and the columns and everything. So user data will be stored in the user defined table. Whereas in system tables, system data will be stored. So for example, there is a table called tab. Tab is one table, and there is another table called user underscore constraints. This is another table. There are n number of tables are there. These are all comes under the system tables. Those tables we don't create, by default it will be there. And user defined tables we need to create, for example emp table or school table, so etc. These are the tables which we need to create, our own tables. These are the two types of tables we have in Oracle: system tables and user defined table. Now if we want to get this data, metadata, this will be stored in the dictionary table. So these are also called as the dictionary tables. Dictionary means it contains all kinds of information, right? So these dictionaries having the data, that is basically called as metadata. So data dictionary tables contains the metadata. Now how we need to get this metadata? So if you want to get the metadata, we need to select the system tables. Okay, for example in the last class we have created some tables with some constraint, right? So if you want to know some table, suppose let us say for employees table, so what are all constraints created on that particular table columns? If you want to know that, we need to write a certain query. Okay, let me show you. Now I have logged in as a HR user here. So when I say select the star from, I have a table called as user constraints. For example, let us say user underscore constraint. So one more important thing is here, these tables, system tables can be accessed by only administrator users. Okay, normal user cannot access. Now here user underscore constraints. This is a system defined table. So when I execute this, it will give you some information. Select star from user constraints. It have a lot of information. So it contains the different owners and what is the constraint names, constraint type, table name. There are number of tables and each table having number of columns, and their constraints will be displayed in this table. But what I want to get from this table is especially for specific table. For example, I have an employees table. specific to the employees table columns, what are all constraints have been created. That information I want. Okay, so how we can get the data? So this is a part of a validation which we need to do. Okay, so if you want to validate the schema of the tables, then this query is very much useful. So the query will be like this: select. Okay, so we want to display the table name also, right? So table underscore name. There is a column called table name. So it's a table name, the first column you can see, not this one. Owner constraint name. Somewhere it should be the table name. Index invalid. Okay, we will see that part. Owner constraint name. Yeah, this is the table name. So select table name, and there is a constraint name. So this is a constraint name. So exert query the column constraint underscore name comma constraint type. So there is a constraint type. So here constraint type is in the sense every constraint we have a shortcut key. For example, R means a referential integrity. Okay, C means check constraint, U means unique constraints, P means primary key constraint. So this is a shortcut basically. Okay, that is a constraint type. By seeing the first letter we can understand what kind of constraint it is. So constraint type from the table is user underscore constraints. So if I say like this, it will give you all the table names, all the constraint names considered for every table. But I want to get one specific table. So we need to filter with the where condition, where table underscore name equal to, suppose I am giving employees. This is my table. Now we have filtered the data. So on the only especially employee table, what are all constraints have been created. So that information we will get here. So table name, constraint name, and constraint type. So when you want to validate the constraints which are created on the table, we need to execute this query. By using this query, we can validate whether proper constraints have been created on the table or not. That information we will get. Okay. So this is simple information. This is a continuation of last class. Now we will move on to the next concept called as set operators, joins, and subquery. These three are very important before going to the ETL testing part. Okay, so let us see this one. First, let us discuss about the set operators. Set operator. We will see so many examples and everything. Set operators. So in Oracle, we have 4 set operators. So basically, what is the use of set operators, sir? Set operators are used for getting the data from multiple tables. See, there are 3 ways we have to get the data from the multiple tables. So far, we retrieve the data from the single table, right? But if you want to get the data from the multiple tables, there should be some relationship between multiple tables. At least 2 tables we require. And the relation is also must be there if you want to get the data from multiple tables. Now, in Oracle, there are 3 ways we have to get the data from multiple tables. One is by using set operators. The second one is by using joins. The third way is by using subqueries. These are the 3 different ways we can get the data from multiple tables. So these 3 different things we will discuss today: set operators, joins, and subqueries. These are the 3 different ways we can get the data from multiple tables. Now let us see set operators. There are 4 set operators are there: union, union all, intersect, and minus. So among these, minus is very important as part of ETL testing, because we need to find, after transforming the data from source to destination, we need to check the source table should be exactly the same as in the target table or not. That we need to verify using minus query. Okay, so these are the set operators: union, union all, intersect, and minus. Let me share my presentation, then it will be here. Just a moment. Right. So union, union all, intersect, and minus. So these are the 4 set operators we have. Now the rule before using these set operators, at least we require 2 tables. At least we require two tables. And we can also have one table. We can use union all intersect minus on one table, but we need to create two aliases for one table. But usually if you have more than one table, we prefer to use set operators. Now here the condition is, if you have two tables, if you want to join those two tables, or if you want to get the data from two tables, the columns should be same data type and in the all the tables, at least columns. So for example, in the first table we have two columns. In the second table is also we have a two columns. All two columns should be the exactly the same data type in the two tables, both the tables. So then only we can use your set operators. But that is again limitation here. So that's the reason joins came into the picture. So when we need to use set operators can be used only if you have the same data type in the all the tables. Column should be having the same data type. Column names can be different, but data type should be same. So in that particular case, we need to use set operators. If the columns data type is not same, then we can go for joins or subqueries. But the set operators can be applied only if the same data type of column should be there. Now we will see few examples here. Let me create two tables. Let us create A and B. Then we will see what is the usage of union all, intersect and minus. So let me start this here under HR1. I'll create two tables. First table is create table A. My table name is A. So here I'll say S name. This is a varchar type. Varchar I'll say 15. And the other column is number, numeric column, S name and S number. This is a number data type, so which contains some two numbers. So this is my simple table. Sorry, this is a open brace. Here it need to close brace. We can also write in the single line. So this is a table I have created. So now, sorry, it was starting at line number 5. So sorry, something wrong here. Here we need to give comma. Fine. So now execute. Error starting at line number is wrong. Create table A, yes name varchar 2 of 15, comma number of 2 is wrong here. Okay, sorry, this is a semicolon. Sorry, just a minute. I give something wrong here. This is the correct semicolon should be end. Okay. Name is already used by an existing object. I think that name is already there. Let me remove if it's already there. Yeah, A is already there. Just remove this. How to drop a table? What is the command? Second. How to drop a table? The command is drop table A. So drop this. Table is dropped. Now it will create a new table. So now table A is created. So currently I don't have any data in the table. Now I'll insert few records on the table A. So how to insert the record? Insert into table A values. So there are two columns. First one is S name, second one is number. So S name is always we need to put in the single quotes. So let us say ABC and comma number is 10. So this is one value. I'll enter. And similarly, I'll insert multiple records. You can execute all the statement at same time. 1 second. Control V, 3, 4, 5 records. I'll enter 5 records. I'll change these values X, Y, Z, Q, R, some names. Okay, so I'll also send this, change this 30, 40, and 50. Okay, so now I'll insert these records in a table. All inserts, select and execute to A values. Oh, sorry, spelling mistake. This is values, right? Values. This is values. Right. Values. Now execute. So now 3 4 5 rows are inserted. Once as soon as you inserted, just execute the commit command, because the rows will be saved permanently. Otherwise the rows will not be saved permanently. If you open the next session, data will be lost. So whenever you when you do insert or update, then you immediately execute the commit command. Okay, now let us see the records in a table A. Select star from A. So execute this command, it will give you the record. So these are the records we have in the table A. Now we will also create table B. So this is the table A. Let me create another table. Create table B. So now which contains again two columns. One is number. This is a numeric data type. Let us say 2. And the other column is grade. This is varchar 2 of something called, suppose let us say 3. Okay, so this is a table. Now execute this. This will create a table. B is created. Now first column is number, second column is grade. So we have a two tables now. So let us insert few records in the table B. Insert into B values of, so first for number, right? So number, comma, the value is A, grade is A. Similarly, I will insert few more records. 4 5 records. This is 12, 13, 14 and 15. Let us say this is B, this is C, again this is A, this is B. Now execute all the statements. Now rows are inserted in the table B. Commit those records. Commit those records. Okay, records are committed. Now let us see what are all records we have in the both the tables. Select star from A and select star from B. You can clear this. Now execute both of the things, you will get the both the records. Okay, now this is A table and this is the B table. Now in the both the tables we have a number column, right? And also same, and also S name is a varchar. Here S name is also a varchar. So both the tables exactly the same. So we can join these tables because the condition is met. So what is the condition? Columns should be the same data type in all the tables. Both the tables here, the columns are the same data type. Here we have S number, here number, and here S name, and here grade. Both are varchar type. So we can join these tables. So how we can join these tables? First let us say union. What is union? How it will work? So union will basically combine all the records from table 1 to table 2. It will also give the duplicate records. So for example, when I say here, 1 second. So for example, in the table A, this is my A table and this is my B table. Okay, here I have 1 2 3, here 4 5 6. Now when I say union, it will give all the records from table A, all the records from table B. So it will join all the records 1 2 3 4 5 6. Okay, for example, if there is any duplicate table, for example here 4 is also there, 5 is also there. Now it will give you 1 2 3 4 5 from table A, again 4 5 6 from table B, 4 5 6. So if I see here, these are the duplicates, right? So when I use union, it will join the two tables and get the data, but the data can have duplicate values. Okay, the data can have duplicates. Oh, sorry. If I use union, it will not display the duplicates. If I use union all operator, then it will include the duplicates also. There is a difference between union and union all. So first let us see the only union part. How to write the query now? Select num column. I am taking only num column because that is a common for both the tables. Num from A, union, select num from B. So when I execute this, it will give you all the records 10, 11, 12, 13. These are the records from, sorry, num from A, union, num from B. So all the A records as well as the B records. All records we got it. So if I see here, A contains 11, 12, 13, 14, 15. B contains, sorry, this one, 10 20 30 40 50. Here 11 12 13 14 15. So I think 15 is all, no, there are no duplicate records here in the table itself. But usually if there is any duplicates, it will also display the duplicate values. Okay, so here this query displays all the records from multiple tables without duplicates. This is important part, without duplicates. Okay, remember this. Now in the same query, let me execute once again. Execute. Now we got this data, right? Now is there any duplicates are there here? There is no duplicate record. Insert one duplicate record. So for example, let us insert select star from A. A contains 10 20 30, right? The same 10 20 30 I will insert in B. Okay, so here select a star from B. So B is also number 10 20 30 is not there in the B, so I will insert those records. So insert into B values. So first one number I'll insert 10 comma grade something called A, duplicate, and insert into B values. Here also I'll insert 20. 20 is not there in B. I'm inserting because these values are there in the table A. I'll insert as B here. Okay, execute them, inserted, commit, execute. Okay, now we have a duplicate reports in both the tables. Now let us execute A and B. Clear this. So when I execute this A and B, we have a duplicate records 10 20 30 40 50. Here also 10 20 is the duplicate values. Now when I execute this join only with the union, it will give you the duplicate records. When I see here 10 is printed here, 11 12 13 14 15 20 30, sorry, it will not give the duplicates, it will eliminate the duplicates, right? That is all about the union. But the same query, if I execute with the union all, just say union space all, and this will query will give you the duplicate entries. See now, so 10 20 30, here 10 20 is there in the table B also, so it is also getting the duplicates. So union means it will give you unique values without duplicates. It will just basically eliminate the duplicates. And if I use union all, it will get the data from the both the tables including duplicate values. That is the another. So displays all the records for multiple tables including duplicates. Now I want to get the data, common data between the two tables. Common data, that is basically intersect data. Intersection means common data. For example, here I have two tables. Only 20 30 is the common. This is one table. This is another table. This is A and B. So in the both the tables 20 30 are the common values. So I want to get only the common values. Then I need to go for intersect. Select num from A, intersect, again select num from B. So basically it will return the intersect common values in the both the tables. We have only 10 and 20, so this will returns the common values from both the tables. And there is another operator, that is minus. Minus means, let me show you here. Suppose I have a table 1, this is A. I have a table 2, this is B. There are two tables. Now here we have a 1 2 3. Okay, so here we have a 2 3 4 5. Here we have a 6 7 also. Okay, now if I see both the tables, when I say union, what are all we will get? Union means 1 2, duplicates will be eliminated, right? So 1 2 3 4 5 6 and 7 we will get. Okay, 1 2 3 4 5 6 and 7, all the values without duplicates. Now when I use union all, then what are the things we will get? It will get all the things, but it will eliminate the duplicates. So 1 2 3 4 5 6 and 7. So here 1 2 3 is there, 2 3 here is there, right? So it will union all means here 1 2 3, again it will give 2 3 also, because it will also include the duplicates. Now intersect means it is common, so between these two bells only 2 3 are common. 2 3 here is there, here it is there, so only it will give the 2 comma 3. Now when I say minus, suppose a minus b, so select star from A minus select star from B. When I say like this, it will return the data like values will be there in the table A which are not there in the table B. Only those values we will get. Values are there in the table A, right side table, which are not there in the B, that is A minus B. So what are those values? 6 and 7. 6 and 7 is there in the A, but they are not there in the B. So this will return 6 and 7. And if I say B minus A, for example, select star from B minus select star from A. Now this will return the records which are present in the B, those are not present in the table A. So what are those records? 4 and 5 are present in the B, but their records are not present in the table A. So this will return 4 and 5. This is a minus query. Okay. Now let us execute and see. So select star from A minus select star from B minus query. So now this will give you what is expression, sorry, not star, we should get the same column, number and number column. Execute. See now 30 40 50, these values are there in the table A but not there in the table B. Now when I execute the second same query in the reverse way, this is B minus this is A. Now this will give you the values are there in the table A, but those values are not there in the table B. 11, 12, 13, 14, 15 are not there in the table B. So this is basically called as minus query. Okay, fine. So these are all set operators. So what is the limitation in the set operators we have? So the limitation is we should have the same data type of the columns. The column should be the same data type in the all the tables. So then only we can use set operators. So that's the limitation we have in the set operators. So to overcome this particular limitation, we will move on to the another way, that is joins, SQL joins. Okay. So now we will see that prerequisite same. So for example, set operators also can be used more than one table to joining the data or to get the data from the multiple tables. Similarly, joins and subqueries are also used for getting the data from multiple tables, but there are some restrictions. Like set operators can be used only if you have the same data type column on the multiple tables. But if you don't have the same data type columns in the multiple tables, we cannot use set operators. Now let us move on to the next concept, that is joins. So joins are basically used for joining the data from one or more tables. We can also join a table with the same table. Okay. So joins are used for joining the data from one or more tables. So we have multiple types of joins: outer join, inner join, cross join, and self join. Outer join, inner join, cross join, and self join. So outer join is again divided into three different categories: right outer join, left outer join, and full outer join. So these are the different types of joins. Now let us see how these joins will work with simple example. So let us see this picture. So if you understand this picture, it is very easy for you how to work with the joins. Very simple example. See now here I have a table 1 which contains a column called number ID which have some numbers, and this can be applicable for set operator also. Okay, same concept, but only thing is here we are using the joins concept. So here we have a table 1 which contains few numbers, and we have a table 2 which is also contains with few numbers. There are two tables, table 1 and the table 2. Table 1 contains 12, 14, 10 and 11. Table 2 contains 13, 15, 11 and 12. Now, inner join means, first let us discuss the inner join. Inner join is nothing but just like an intersection. Intersection means it will display the common records between the two tables. Common records. So for example, if I see the table 1 area, what are the values we have? 10, 11, 12 and 14. These are the records we have in the table 1. And the table 2 we have 13, 15, 11 and the 12. These are the records we have in the table 2. So what are the common records we have? 11 and 12. So these are the common records we have in the both the tables. Now inner join will return the common records between the two tables. Common records. So how to write the query now? Select star from table 1, inner join. So in Oracle we can write joins in the two different notations. Okay, I'll tell you both the notation. This is a one of the notation. Okay, so by using keywords, inner join, outer join, we can directly use these keywords. And without using these keywords also we can write joins. That is another notation. I'll tell you that one. So inner join means select star from table 1, inner join, table 2. So here we no need to use again one more select statement. Simple. Select star from table 1, inner join, table 2. We are joining two tables, but we must specify one condition. On which condition, on which column we need to put the condition? What is the common column here? Num id is a common column. We can have any number of columns, but the condition should be there in one column. Okay? There should be the common column present in both the tables. Now here select star from table 1, inner join, table 2 on, this is the syntax, table 1 dot numid equal to table 2 dot numid. If this condition matches, only those records will be displayed. So in the table 1, number id should be matched with the table number 2 number id. What are those records? 11 and 12. So here 11 and 10 match with the 11 and 12 here. Sorry, 11 and 12 match with the 11 and 12 in the table B. Only those records will be retrieved. So the result will be 11 and 12. So this is basically called as inner join. It will return the common records between multiple tables based on the equality of condition. The condition mandatorily required. That is the one category of join, inner join. Next, outer join. We will see cross join, self join later. So outer join. So outer join we have again three different of joins. Left outer join, right outer join, full outer join. In outer join we have three different notations. Right outer join, left outer join, full outer join. This is just like a minus operator. So when I say A minus B, what happens? It will return the records which are there in the table A but which are not there in the table B. Similarly, if I say that is basically right outer join. So we'll get the records from right table which are not there in the left table. Okay, and similarly left outer join will get the records from the left table which are not there in the right table. Basically this is minus operator. Okay, and full outer join means it will give the all the records from table A and the table B. Okay, the records which are there in table A which are not there in table B, those records, plus and the records which are there in the table B and which are not there in the table A. It will combine those records and will give the result. That is a full outer join. So right outer join, left outer join and full outer join. Now let us see the data. How to write left outer join, right outer join and full outer join. But the condition is same. Okay. See now, first let us see left outer join. Select star from table 1, left outer join, table 2 on table 1 dot numid equal to table 2 dot numid. So what this will return, as I said, the records which are present in table 1 and those are not there, those records are not there in the table 2. Only those records will be displayed. So if I say here 10 is there in the table 1 but it is not there in the table 2. So 10 is captured. 14 is there in the table 1 that is not there in the table 2. So 14 is captured. 11 and 12. What is 11 and 12 here? So start from table 1, left outer join, why 11 and 12 is came. So 11 and 12, select star from table 1, left outer join table 2 on table 1 dot num id equal to table 2 dot num id. So 10, 14, 11 and 12. 11 and 12 is already there, right? So but is there any matching records? Table 1 dot num id to table 2 dot num id. What are all records will be matched with this condition? Table 1 dot num id, table 2 dot num id. Only matching records. What are those matching records? Only 12 and 11. 11 and 12. Yes, matching records plus, yes, yes, 11 and 12. So 11 and 12, sorry, 12 and 11. 12 and 11 is the matching record. So 12 and 11 or matching records plus the records which are there in the table, both will be printed. And similarly, right outer join the same way, the records which are there in the left table which are not there in the right table, that is 13 and 15, and also the common records, that is 11 and 12. So these records will be printed as a right outer join. Next, full outer join. Full outer join will get the all the records like 10, 14, 11 and 12. These are from left outer join and also from right outer join. What are the values? 11, 12, 13 and the 15. So it's a combination of left outer join and the right outer join. Both will combine, will get the records. Now we will see a few examples on this. So when I see, if you want to write the join queries, this is the way. This is one kind of notation. You can use keywords like inner join. Is full outer join like union? Yes, yes. But in union, you should have the same data type. That is the restriction we have. But here we don't need restriction. Okay, fine. Yes. Now come to the join queries. Basically here, this is the one kind of notation we have: inner join, right outer join, a left outer join, full outer join. These are the keywords. Okay, these are the keywords. Red color highlighted are the keywords. So how we need to write? This is the first kind of notation. Select star from A, inner join B on A dot num equal to B dot num. This is a equi-join, basically called as equi-join or inner join. Both are same. So inner join is also called as equi-join because we are specifying the condition, equality condition. And right outer join. So select star from A, right outer join B on A dot num equal to B dot num. So this will give the records from the right table which are not there in the second table and also the common records. Similarly, left outer join will give the records which are there in the B, but the same records are not there in the table A, and also the common records, that is left outer join plus full outer join. Full outer join will give you all the records from right outer join as well as left outer join. Now let us see a few examples. I said two notations we can write, right? So the first notation can be by using keywords. The second notation can be by using uh, the operator. So for example, here see equi-join. How we have written here? I am applying on the employee table. So select EMP number, e-name, job, and department number, d-name, location from EMP, department. So I am taking two tables here, employee table as well as department table, both the tables, and I want to get the records like employee number, e-name, job, and these records I want to get from the employee table from EMP, and DEPT number will be available on the DEPT table. So we need to get these records from the both the tables, but condition should be like this. So in employee table is also DEPT number column is there, but in the department tables also we have a DEPT number. So we need to compare employee table department number equal to department table department number. If those records are matched, only we will get those records. Okay, but here DEPT number is there in the employee table as well as department table, right? So that's the reason what we need to do is, when I selecting these records from EMP or DEPT, we have to use alias name. Okay, alias name. And also when I want to retrieve the columns, dbit number here we are retrieving, right? And here also we are specifying the condition. So if I don't use alias, this will be confused. Which department number comes from which table? It doesn't know basically. So that's the reason what we need to do is we need to create an alias for EMPE department D, and we need to, whenever we retrieve the column value here, we need to specify the alias name. So when I say D dot department number, this department number will come from the department table, because D is a alias of department table. Okay, so select EMP number, E name, job. These columns are from normal employee table. Especially department number is a common for both the tables. That's the reason for department number column I have used alias. Other columns not required, because EMP number, E name, job will be available in employee table, but they are in the department table. So that for these columns alias is not required. But especially even D name and location, these two columns also doesn't require alias, because DEPT table we have these records, but employee table we don't have these records. Okay, that's the reason these two columns also not required alias. But especially DEPT number we should require alias, because this column is available on the both the tables, employee as well as DEPT tables. So the condition will be E dot DPPT number, that means employee table department number equal to D dot department number, that is department table dot department number. So let us write this query and see. So select, we have here employees table and departments. There are two tables, not here under HR. So first let us see, select star from employees, and then select a star from departments. Okay, so let us execute the employees, and this is contains a DEPT column, department underscore ID we have. So this is a common column, department underscore ID, and the same column will be available under departments. Here department ID is there. Okay, so what I want to get the data here is whatever the data we have employee table, all records I want, but the condition is this department number should be matched with the department number which is there in the department table. See, in the department table there are many number of departments are there, but in employees table every employee belongs to certain department. But in the employees table there are many number of department IDs, which sometimes those department IDs are not part of departments tables. So I want to get those records. So how we need to write the query now? Select first employee number, EMP ID, employee underscore ID. This is from employee table, right? So we no need to use alias, employee ID, and first name, comma, and also I want to get the what is there else, salary, and these the columns come from the employee table. Okay, comma, I want to get the few more columns from department table. For example, set the department table. So I want to get the department ID from department table. Let us get the two, department ID also department name. Okay, because department name is not there in the employee table. So apart from these details, I want to get department ID and department name. Okay, so now I want to retrieve these columns. So department underscore ID, comma, department underscore name. First, don't use any alias, so just write the query from employees. Okay, don't write any alias, employees, comma, departments. This is the query. Now I need to put the condition where department, let me write in the next line, department underscore ID equal to department underscore ID. If I say like this, it will throw an issue, because here it doesn't know basically this department ID we are using, right? Which department ID belongs to employees table and which department IDs belongs to departments table. It doesn't know basically. So Whenever we are specifying the table name, we must specify the alias name. This is E. Let us say this is D. That is the one thing. Even though specifying the aliases, it will throw an exception here. So what is an exception it will throw is this one. Here department ID is equal to department ID. We have written condition, but which department IDs belongs to which table? That we need to specify. E dot department ID equal to this is D dot department ID. So E represents the employees table, D represents the department table. Now execute. You will again get the issue here. Now observe this. So here the error is because of this one and this one. So department name is there in the department table, that is no problem. But the problem with the department ID here. So this should be, we need to mention from which table. So let us see, for example, let us say this is D dot department underscore ID. So now let us execute this. Select command. Execute. Now we get the employee ID, first name, salary. So these details are come from the employee table, but department ID and the D name will come from the department table, employee table and department table. This condition should be matched. And also we need to, if you have the same column in the both the tables, we must differentiate those columns by using aliases. Okay, so this is the one of the notation we can write. So there is also one more notation. So here we have this is simply equi-join or called as inner join. Okay, and there is another way we can also write here. So let me show you the same query. I write like this, the other format. And here select same query. I'll write again. I'll change a small thing. So select employee ID, first name, salary, D dot department number, okay, D name from employees E, department D till this fine, right? So now instead of where condition here, where E dot department ID equal to D dot department D ID, I'm writing, right? So instead of this, simply I can use where. Instead of using where, I can simply use inner join keyword, or you can say simple, this is inner join, space should be there, or you can use simply join or inner join. Now we can use this keyword like this. Here if I use keyword, we don't need to specify the condition, but we need to specify the condition, but we need to put that into the brackets. So join, see, employee ID, first name, salary, department ID, department name from employees E, and department employees E. Here we need to use join, sorry, here we need to use join, inner join, with which table? Departments table. Which departments table? On which column? On this column. We need to put this in the bracket. So this is another notation we have. Now we can simply understand. Select employee ID, first name, salary, department ID, department from employees E. And which table we need to join? Inner join with departments table. On which column? Department ID dot department ID. So this we need to specify. This is the another notation we have. One is directly we can say where condition and condition here with the where, and the other one is by using keyword, inner join, outer join, left outer join. We can directly use the keyword. So this is another notation we have. So put the semicolon here. So this will also give the same result. Stable your view does not exist. Something wrong here. Departments employees E, inner join departments or department. Select employee ID, first name, salary, and D dot department ID, department name, department underscore name from employees E. So here we no need to use comma. Okay, so inner join, simple. So we should not put any comma there. So execute this. Right, so now we need to get the same data again. So this is another notation by using inner join keyword. So this is basically called as ANSI format. Okay. So in Oracle, we can write joins in two different formats, and some people will write like this and some people will like this, because the second method is a standard method, because SQL is the language which is common across all the databases like Oracle, SQL Server, MySQL, DB2. Every database follows the same standard. But this is a very specific to Oracle format. The first method we have written, right? So this is specific to Oracle format. So this will work only on the Oracle, not other databases. If you execute the same query in SQL Server, some other DB2, it will not work. So other databases mostly follow the second syntax: inner join, outer join, self outer join. The C keyword they will use. Okay. So always when I write the joins or subqueries, not join subqueries, when I want to write the joins, you need to use the second notation. Always you need to follow second notation, because the sources and targets databases can be different kinds of database, not always the same database. So whatever query you have written, that should be uh, sync with all the databases SQL commands. Okay. So the first one is specific to Oracle, and the second format is the generic format. This is generic format. Fine. So now let us continue with a few more things. So this is basically right order join. Sorry, 1 second. EP join. So for what we discussed is EP join or inner join. This is an example I have told you just now. And similarly, we can also write right order join. So right order join format will be like this. The first format is, this is Oracle format. Select employee number, ename, job, d dot department number, dname, location from emp, e, comma, department table d, aliases, where condition with the condition. So this is right outer join, right? So we need to use this operator. Within the brackets, we need to use plus. Now this will give you the records which are there in the employee table but which are not there in the department table, and also the common records. Okay, so that is the right order join. So here the rule is, it will give the matched records plus unmatched from right table. Matched records means the common records, unmatched from right table, unmatched from right table. So this is the first format, and this is not generic format. This is not generic across all the databases. So the second one is a generic. So now if I see the second one, select emp number, ename, job, d dot department number, dname, location from emp, e, alias, right outer join, department number d. So we are joining emp and department. On here we need to specify the condition, e dot department number equal to d dot department number. So here we don't need to use plus, because here the first notation plus we have put in the right side, because this is the right outer join. Okay, if it is a left outer join, we need to put this plus at the left side. Okay, based upon the location, it will get the records. But here equal condition should be matched, and right order join keyword will take care of getting the records at the runtime. Okay, so that is the second notation we have. First and second notations. Second notations is the standard format everywhere. Similarly, even left order join also we need to write the same thing, but if you observe here, the plus will come here. Plus is in the, now it is the left side, so it will give you the records from the left side table which are not there in the right table, and also the common records. That is left outer join. So left outer join, match records plus unmatched from left table, matched records plus unmatched table from unmatched records from left table. So those records it will get. And the second format is select emp number, ename, job, department number, dname, location from employee, e. Instead of using plus here, that is another notation we use, left outer join. Instead of right outer join, just we need to use left outer join. Condition and the query exactly the same. Instead of right outer join, we need to use left outer join. If it is a full outer join, just you need to use full outer join. So here, select all the columns from employee and department, and then use full outer join keyword. So it will give the all the matched records plus unmatched records from both the tables. Okay, So these are the two different notations we can follow while writing the joins in the Oracle. Is it clear everyone how to use joins? So if you understand this particular diagram, it is very easy to get you, no confusion at all. Okay, this is just thumb rule. Okay, inner join or equi-join, left outer join, right outer join, and full outer join. Okay, so again we have cross join means it is basically union. So union will give all the duplicate records, right? Similarly, cross join we can use. Just select star from employee, cross join, select star from department. So it will give all the records combinations. That is basically called cross join. All the combinations will be. And self join is different. Suppose if you have one table, and if you want to join one table with the same table, then we need to go for the self join. Let us see those joins. Self join with the table with the same table, joining the table with the same table. Now if you observe this, a query here, employees table. In the table, I want to get employee ID and that particular employee ID first name and their manager ID also I want to get. Their manager ID. So employee ID here, first name here, who is his manager? Who is his manager? How we will know? Based upon the ID. If I see here, last name, email, phone number, hided, job ID, salary, commission, manager ID is here. These are the manager IDs. So even the manager is also an employee in the same table, right? Manager is also an employee. So I want to get employee ID, first name and their manager name not manager ID. Manager name I want to get. So how I need to get? Let me write the query here. Very simple. So first select employee ID, comma first name from employees. This is fine. So when I say this one, first name, and also execute this first of all. If I execute this, this will give you the employee ID first name from employees. But I want to get the third column. So what is the third column? For example, if I say his manager ID. So what is the column of manager ID? Let us select star from employees. So what is the column ID of manager? Manager underscore ID. So let me get that also. Manager underscore ID. So when I execute this, it will give you the employee ID, first name and the manager ID. But I want to get also manager name. That's my requirement. I want to get also manager name. How we need to get? We don't have the manager name as a special column, right? Separate column we don't have. Only manager ID we have. So now what we need to do is, we know the manager ID, right? So based upon the manager ID, we need to check that manager ID and employee ID. If both are equal, then we need to get the name of the particular employee, particular manager. So now employee ID and the manager ID, both are there in the same table. Now we need to join these two tables. How we need to do? Let us say, give me one example here. So here I have, one second. Okay. Now I have a table called employee. This is my employee table, and I have employee ID column. And I'll make this as a two references. One is E alias, and the other is M. Both are aliases for employee. Now we have one employee table here, one we have employee table here, and here we have called EMP ID column, and here apart from the EMP ID column, we have also manager ID column. Now we need to compare this one with the manager ID. If both are equal, and get the name of that employee. That becomes the manager of that particular employee. So here table is same. We have only one table, but by using alias names, we are pointing to the same table and we are getting the data from the same table. That is basically called as a self join. Okay, now let us implement the code. How we can write the query. See now, so now select employee id from which table, e dot employee id, and first name also from e, and manager id, and from employees manager id, and also I need manager name, manager manager underscore, let us see, manager underscore name, we don't have special column, right? That is also first name. So what we can say here is first name. Let us again put first name, but this first name comes from employee, this is also from employee, but this is, let us say, m is another alias for the same. From employees table, from employees, now we need to put the condition where e dot, what is manager id, manager underscore id, or we can say uh, employee id equal to m dot manager underscore id. We need to reverse this one because we need to check with the manager id with employee id. So here we need to use manager id equal to m dot, here we need to use employee underscore id. Okay, so this e dot manager id dot equal to m dot manager id. Now what are all columns we need to get from which table? Employee id is from employee table, first name is also from employee table, manager id is from manager id is from, let us say, e, and first name is from m, from employees comma, here we need to specify the alias, right, comma, and departments table, this is, sorry, not departments, same table again, employees e comma, again same table, employees m, same table, right? So now this is a query. Same table we are creating two aliases. Two aliases means it will consider as a two tables, and from one table it is getting the employee id first name, and from other table it is getting the manager id in the first name, but the condition is same manager id should be matched with the employee id. Now execute this. M dot first name is invalid identifier, it should be e dot first name. Sorry, first name is something wrong. Okay, now we can see employee id first name, again the first name is came as the same. See now this is wrong, right? This should come as a manager id, whoever is 100, that manager id we should be displayed here. So this is wrong, so this is m dot manager id. Now you can see, so here employee id first name, their manager id is 148, and the manager name is this one, Gerald. Okay, so this is how we need to write the self join. Self join is nothing but getting the data from the same table. Okay, we need to create the two different aliases for that same table and put that condition, so same table again. Okay, so this is one of the example of self join. Now let us move on to the other one. So these are all about the join. So is it clear everyone? Outer join, inner join, cross join, and self join. Yes, so just remember this picture, so it will be very clear. Okay, no confusion. You will get a lot of interview questions on this. I'll also give you for a few assignments today and joins and group by class and having whatever we discussed so far in the previous classes. I'll give you the assignments, you can write your own queries. Okay, now let us move on to the other one called sub queries. So the other way of getting the data from multiple tables is concept is subqueries. So by using subquery, we can get the data from multiple tables. So what is subquery? Subquery is basically a query within a query. Query within a query is called as a subquery. So we have two types of queries, so outer query and inner query. Outer query will be there. The outer query will get the input from the inner query. Okay, so the output of inner query is become the input of the outer query. I'll tell you how we need to use single row subqueries, multi row subqueries. There are two types of subqueries we have. Let us see example, then you will understand. Now I have some requirement here. What is my requirement is display employees whose salary is, okay, so for example, whose salary is less than of Lisa. So Lisa is an employee, right? She's having some salary here. This is my requirement. I want to display employee details whose salary is less than of Lisa. So this is a little bit indirect query. Display the employees whose salaries is less than of Lisa. So first of all, what we need to understand here, first we should know what is the salary of Lisa, and then we can say we will get the all the salaries which are less than of Lisa salaries, right? So there are two things are involved here. One is first we need to know the what is the salary of Lisa, and then based on that we can get the data which is less than the Lisa salary. Okay, so first if you want to achieve this task, I should create the two queries. So what is the first query I should create? First of all, I need to know the salary. What is the salary of Lisa? So how we need to get select salary from employees where first underscore name equal to Lisa. This is my query. Now with this I will get the salary of Lisa. Now what is my query? Display the employees whose salary is less than the salary of Lisa. Less than the salary of Lisa. So now by this query we know this is the salary of Lisa. Now I can write one more query. Select star from employees where salary less than 11,500. This is the requirement, right? So display all employees whose salary is less than salary of Lisa. This is the salary of Lisa and less than of salary of Lisa. So when I execute this, we will get all the records whose salaries are less than the Lisa's salary. Okay. So if you want to achieve this task, we have to create the two queries. Now instead of writing two queries, we can write single query that becomes a subquery. Now I will combine these two queries. How we need to combine? What is the first query is? We need to get the salary of Lisa. This is the first query. It is giving some output, right? So that output becomes the input of the other query. Put this query in the brackets. Okay, this is inner query, and this will provide you an output. So that output becomes the input of outer query. Now I'll create this particular query as an outer query. Now you see here, select star from employees where salary, here I need to put the less than, and which salary? This query will return the salary. Okay, this is basically called inner query and this is called as outer query. This is basically query, subquery. Subquery means a query within a query is called as a subquery. So we no need to write two statements like this. Okay, so this inner query will return an output. That output will become input of the outer query. So this is a one example. Now I'll write one more. I want to get second maximum salary from employees table. Second max salary from employees table. Second maximum salary. How we will get this? If you want to know the highest salary, then we can get the lowest salary, right? First of all, second max salary. I'm not saying highest salary. If I want to get maximum salary in the EMP table, simply we can write like this. But that is not my requirement. Select max of salary. If I write like this, from employees, this query will return the maximum salary of employee. But this is not my requirement. My requirement is I want to get the second maximum salary of employee. Second maximum means the salary should be less than this one, but that should not be any other salary. It should not be, all salary should be less than that particular salary. So this is basically maximum salary. We should get the second maximum salary of employee. Now how we can write the subquery? This is maximum salary we will get if I use this one, but I want to get the second maximum salary. Second maximum salary, and remember this. Now I need to write two queries. Okay, so this is will give you maximum salary. Now I want to get the based on this I need to get the second maximum. How we need to write the query now? Select again max of sal. So first let us say sal, for example, salary from employees where salary less than 24,000. If I give like this, what will happen? By using the first query, we got the maximum salary. By using the second query, we will get the all the salaries which are less than 24,000. All the salaries which are less than 24,000. Salary from where salary. So this query will return the all the salaries which are less than 24,000. But I don't want all the salaries. I want only one salary which is less than this salary and which should be highest of all other salaries. That is basically called second maximum, right? Now what you need to do, instead of getting all the salaries among them, again I want to get the highest salary of these salaries. Among these salaries I want to get the highest salary. That becomes the second highest, right? Anyway we got the highest salary. Salary less than 24,000. Condition is mentioned. So this result, this query will result the all the salaries which are less than 24,000. But among these salaries, I want to get the highest salary. One more highest salary. That becomes the second highest salary. Then what we need to write here? We need to write one more max function. Now what happens? Among those salaries, among these salaries, it will get the highest salary. Highest maximum salary. So that maximum salary is second maximum salary. Will become second maximum salary. Now when I execute this, it will give you the second maximum salary. Now, if you want to get the second maximum salary, I should write two queries normally. Now, how we can achieve this? By using subquery, we can combine this. How we need to combine? So this is become the outer query. This is become outer query, and for this input is required. And the first query will give the highest maximum salary. That becomes the input. Right. So now this one is the inner query, and this one is called as outer query. Now execute the both. Anyway, inner query will return the 24,000. That 24,000 become the input of outer query. So salary here again we need to specify less than condition, right? Now execute this. Same. It will give you the same. This is the second highest salary from employee table. Now similarly, I want to get third maximum salary. Third maximum salary. Third maximum salary. How we need to get now? Third maximum salary means the salary should be less than of this particular salary. Again, this becomes the entire query becomes a sub query. See now, put this entire query again in the sub query. Okay. Now write one more query out. Select again max of salary from employees where salary less than. That's it. This is a nested subquery. See, this is a one query, right? So let me write in multiple. Salary less than select maximum salary from employees, where salary again less than select maximum salary from employees. Here we need to get one more bracket. Okay. So this will give you a third maximum salary. See now, internal query. This is a least subquery, inner subquery, right? This will give you the maximum salary. And when this substitute here, and this query will give you the second maximum salary. and now I want to get the third maximum salary, so it should be less than our second maximum salary. Among them I need to get only one salary. So if I remove this max, what will happen? It will give you all the salaries which are less than second maximum salary, which is less than second maximum salary. But again, among them, I want to get the maximum salary. That becomes the third maximum salary. So this is max and this is max. So now this will give you the third maximum salary in a table. Okay. So this is how we can write multiple subqueries, nested queries. A query within a query. Again, this query having one more inner query, right? So this is basically called as subquery. Okay. Now I'll give you one more example. I want to get, uh, now you need to tell this, display salary of employees. Okay. I want to display salaries of employees or salary of employees whose salary whose salary whose salary is greater than the salary of employee number equal to, let us say, some employee number. Just a moment, let me check some staff and employees. Let us take one employee number, employees. So let us say employee ID is 150. Okay, so employee ID is 150. Now this is my requirement. See, now once again, I want to display the salaries of employees whose salary is greater than the salary of employee number or employee ID 150. So in this query, what I want to retrieve, we need to get the salaries of employees whose salary should be greater than the salary of employee 150. So first of all, we need to know what is the salary of employee 150. Okay, we need to get the salary of this employee, and then we can get other salaries which are greater than this employee salaries. Okay, now how we need to write? First of all, we need to get the salary of this employee, right? How we need to get? First let us write two queries, then we will mix up. Okay, select salary from employees where employee ID equal to 150. So this query will retrieve the salary of this particular employee. Okay, we got one input. Now what is our expected here? Display the salaries of employees whose salary is greater than the salary. So all the salary should be greater than this. Now write one more query. Select the star from employees where salary greater than, I'm saying greater than 2, 3, 4 zeros. This is my requirement, actual requirement. So display salaries of employees. So display the details of employees. So this will give the details of employees where all the salaries should be greater than the salary of this one. So salary of 150, we already know this. So just compare salary greater than 10,000. Now execute this. It will give you the exact result. But now we need to combine these queries. How to combine these queries? We can write one query. So this query becomes the outer query because this required input equal to, within the brackets we need to write this particular column. This will give you the exact, sorry, the second query should be the outer query because this required the salary, right, greater than of this particular input. So this will give you the salary of 150, employee 150. Execute this. Now we'll get the employee salaries. If I see here, all the salary columns should be greater than of 10,000. All salaries should be greater than 10,000. Okay, so this is how we can see few examples. And one more example we will see here, the last example here, the subquery. These are very important for interview perspective also. Now what I want to get here is I want to get employees who are I want to get the employee details who all are earning the highest salary. Highest salary. Display employees who all are earning the highest salary. This is my goal. See, suppose there are 100 employees are working, 100 employees are not having the same salary. Sometimes they are having the same salary, right? Suppose if you say 30,000 is the highest salary, so that 30,000 can be there for multiple employees, right? So this query can be like display employees who are all earning the highest salary. So first of all, what we need to do, we need to find highest salary. What is the highest salary we should know, and then based upon the same salary, how many employees are getting the same salary, that we need to get. So how we need to write the query now here? First thing is we need to get the maximum salary. Select max of salary from employees. This will give you the maximum salary, right? Now how many employees are getting this salary? So select start from employees where salary equal to, okay? So this is another query. So inner query will give you the maximum salary, and this salary, how many employees are getting this particular salary, that details we will get here. Execute. Now there is only one employee who is getting the maximum salary, okay? So this is how we need to write subquery. So what are all so far we discussed? These are all called single row subqueries. These are all called single row subqueries, the first category. So I said two types. Single row subqueries, we can use these operators: less than, greater than, less than or equal to, greater than or equal to, not equal to. So what is the difference between single row subquery, multi-row subquery means? In single row subquery, the inner query is always written a single value. So what are all examples we have seen so far? All inner queries are returning only single value. So we are comparing, we are doing less than, greater than or equal to, we are comparing the particular value because inner queries are returning only single values. And there are sometimes the inner query will return multiple values. So in that case, we cannot use these operators, less than, greater than, equal to. These are all simply work on single value. But if you want to get multiple values from the subquery, we need to go for multi-subquery, multi-row subquery. That is the second category. Okay. Now we will see multi-row subqueries. I'll copy these all examples in your notepad. Subqueries. These are all single row subqueries example. Now we will see multi-row subqueries. Multi-row subqueries. How we can write multi-row subqueries? So I'll give you one example here. Okay, my requirement here is, just listen carefully. Display employees details whose salary is equal to the salary of at least one employee in department ID 10. This is my requirement. First understand this. See, whenever you want to write a subquery, first of all we need to understand this context, and then just if you want to understand this context, we need to split it multiple pieces, okay? Then understand individually, then combine it. So that is the easiest way to write the subquery. Now here, understand this. Display employees whose salary is equal. This is one thing, one piece. Display the employees whose salary is equal to whose salary? The salary of at least one employee in department ID. Okay. So at least, we are saying at least one employee in the department ID 10. So what I'm saying here is we need to get the employees whose salary is equal to the salary of at least one employee in the department. So how we need to get here? First of all, we need to get the salary from employee table where department number is equal to 10. That's the first thing we need to get, right? First thing is we need to get the salary of an employee who are working under department number 10. Then we will get the salary. And then we need to write display employees whose salary is equal to that particular salary. So here we will get number of salaries, right? Not only one salary. If I say select a salary from employee where department number equal to 10. If I write like this, department number 10, there are n number of people are working. So it will retrieve all the salaries. But among those salaries, what I want to get right, so among those salaries, at least one salary should be equal. That is my requirement. So first let us write two queries and then we will combine them. Okay. So first thing, at least one employee in department ID 10. So first let us select salary from employees where department ID equal to 10. When I say like this, it will give you the multiple records. Department ID. If there is only one record we have, let us see one more department. We should have at least multiple records. Select star from employees. We should take one department. We should have more number of employees. 90 is repeated, 60 is repeating. So department ID, let us say 60. Okay, now let us take it instead of 10, let us take 60 here. Okay, so what we need to get first, we need to get the salary of employees who are working under department number 60. So the query is select salary from employees where department ID equal to 60. So if I run this query, it will give you the multiple records. Now among these salaries, what I want to get is display employees whose salary is equal to the salary of, that means among these salaries we should get the salary which is equal to any of these. Okay, suppose there is an X employee, the employee of X should be equal to any one of them. Okay, so that those records I want to get. So now if you combine these queries, this is the first query I have written, right? So this will give you the multiple entries. So among these employees or among these salaries, I want to get employees whose salary equal to at least one salary of this list. Now I need to write second query here. Select star from employees where salary equal to, I cannot mention all these values, right? Equal to operator can be used if you have only single value, but if you have multiple values I need to compare. So instead of this you can use in operator. Here I can mention, right? So let us say 9,000, 6,000, 48,000, 4,800, and again 4,800. Duplicates are there, 4200. This is our requirement. So we need to get the employee details. Those employees salary should be equal to any of these salaries. Again, these salaries has come from the employee table. Whoever the employees are belongs to department number 60. Okay, now we need to run this query now. What is wrong in this? Select, yes, select command is wrong. Select. Execute this. This will give you these many records. So these many records, see the salaries. These salaries should be equal to this salary. The first query returned salaries. Okay. Now we need to combine them. So how we need to combine them? The first query, this is the outer query. In here, these values are returned by this particular query. So now we need to insert this query as a sub query. Now here, this inner query will return the multiple values, right? So multiple values we cannot compare by equal to, less than, greater than, and so on. So that's the reason this is called as a multi-row subquery. Multi-row subquery means the inner subquery will return the multiple values. If you want to compare with the multiple values, we have a special operators. They are in operator, any operator, all operator, in, any, all, in, any, all. So these are the three operators we need to use when you want to use multi-row subquery. Okay, for single row subquery, we are getting only single row from the inner query. So that is the reason we need to use only less than, greater than, less than or equal to, greater than or equal to, not equal. So these operators can be worked on single row subqueries. But if subquery is written multiple rows, we need to use in, any, all. So now we have seen in operator. Now in operator means at least this salary should match with 9,000, 6,400, these any salaries. At least one salary should be matched. At least one. Any one. Suppose I want to match with all the salaries. We can use all or any. So let me give you one more example, then you will understand. This is a subquery actually. I combine these two queries into one query. This is a subquery. I'll give you one more example. So here my example is display, right? So display employees, so display employees whose salary is greater than the at least one at least one employee in department number 60. See, it seems very equal to above query, but it is a little bit different. So display employees whose salary is greater than the at least one employee in department number 60. At least one employee we are saying, but above salary at least one employee department and 60, but here we are saying equal. But whatever salary we are getting, this salary should be either 9,000, 6,000, 4 or 4,200, anything, any one. But here greater than I am saying, greater than means it should not be equal to of any of them. Okay, so first query should be same, because we need to get the salary from department ID 60. So anyway, this will return the number of salaries, but my query here is the salary, employees salary should be greater than of these salaries, all these salaries, greater than of all these salaries. That's my expectation. Okay, now how we need to write the subquery now? So let us see. I'm directly writing the subquery. The same subquery we need to use here, but instead of equal to, in means equal to. In means this salary should be matched with this one 400 or 4,200, any one of the salary. But not my requirement is salary is greater than the at least one employee in department 60. So this will return the multiple salaries. What I'm saying now, greater than, greater than. Even though if you put the greater than, we cannot use greater than because this will return multiple rows, not single row. If subquery returns multiple rows, we need to use greater than of any. Any means this is another keyword. So this will return the multiple values, right? Any means at least all. Any means here all, greater than any. Any means whatever records we get from the inner query, the salary should be greater than of these queries, these values. So those records will be getting. So now let us execute this. See now, if you observe the result of the salary, so these salaries also, let me execute the first query, then you will know it easily. Inner query 16, right? So execute this first. I will execute both. One second. Yeah, semicolon missing. Okay, now I have two queries. The first query contains 9,000, 6,000, 4,800, 4,800, 4,200, right? Now whatever salaries we are getting here, these salaries should be greater than of all these salaries. That's the actual requirement. Okay. So whatever salaries we are getting, these salaries are greater than of all these salaries. That's current requirement. And previous requirement is whatever salaries we are getting, these salaries should be equal of any one of these salaries. That is the previous requirement. Okay, got it? So this is how we need to use operators for multi-row subquery. Multi-row subquery. So similarly, we can also use another operator called all. So let me write the same requirement again. Just slight change. Display employees whose salary is less than the salary of all employees in department number 60. Slight change above requirement. See now we need to get the salary of employees which are working on the department number or department ID 60. Okay, DBIT ID 60. So we will get the multiple salaries same way. Now what is my requirement is I want to get the salaries of employees who are less than of all these salaries. So previous query is a greater than of these salaries. Now current query is a less than of all these queries. Okay. Now what I can use here is simple. I can use select star from employees where salary less than all, another operator. Now select again salary from employees where department ID equal to 60. This is a query. So this will return again if I execute only inner subquery. Something wrong here. Department ID. Okay, execute this inner query. Say I can execute only inner query. Even if you write full query, so based upon the selection, it will execute only this particular query. Okay, if I execute this one, it will give you this result. Now among these results, what I want to get is all these salaries. What I want to get is I want to get the salary. That salary should be less than of all these salaries. Less than of all these salaries. So now when I execute this one, you will get the salaries which are less than of those salaries. So if you want to get clearly, you can execute two queries, then you will get difference. Execute these two. Now you can see what are salaries 9,000, 6,000. With these salaries, we don't find any records here. But whatever salaries you are getting here, these are all salaries are less than of these salaries. Okay, all salaries are less than of all these salaries. So this is how we need to write the multi-row subqueries. Multi-row subqueries, single row subqueries and multi-row subqueries. So is it clear everyone now? So now, so I'll stop the session for today here. So now I'll give you for few assignments. Okay, so on join subqueries and set operators, and also in previous classes like group by class, having class and other stuff. So I'll copy all these assignments in the Google Drive. I'll create one more file for assignments, so you can check it there after some time or tomorrow sometime back. So you can practice all these queries based upon the context. Okay, so I'll take one more session for SQL. That will be part of DCL commands, other data control DCL commands, and then once we completed them, then also we have a views and indexes. So once we have finished them, then we will move on to the ETL testing part. That will be in the next week. Okay. Any questions so far? Anyone? Any questions so far? Anyone?